Okay, so this article has been written like how Java memory works, and basically we all know, but let's just go with it and see what happens. So basically, they are also saying before we move on to performance things, we need to learn like how the real background of Java is, right? It's called JVM. So this will be the starting point for every developer and how you will tune performances, how you will gain some speed, how you will actually do the first step when you go toward the worlds of code. So basically in Java memory, what we will have? We will have two things. One will be called stack and second will be called heap. So you will have like stack, you know that it can be a normal stack kind of a thing where you put one thing into another and the first in will be the last out. Heap is something else. Heap sort you have written, but these two things will be different. Let's go and see what is a stack in terms of JVM. So first reason we are going to learn is like stack, right? So JVM, the stack is very different. Okay. It doesn't only like just one, but also every thread inside the JVM will have its own stack. That means JVM will have stack, your things will have stack. Suppose you have a multi-threaded application, every thread of your application will have its own stack. So what we are going to do, so in stack, what we will have is what all the fields you have instantiated, which will be added to memory, one or another, just like we normal do stacking, like I told you, one after another, right? But as you can see, this area here is not big enough. So how will you store the objects? That will be happening is like you will only store the primitive types and the object pointer instead of storing the whole object. So what you will store here? The primitive data types like int and all and the object pointers in the stack. So if you see, this is a very good structure where you are putting values in stack one by one. Okay. And you can, as we know, you cannot remove the first object needs to be removed first because as I said, the data is stacked. We can't reach the bottom unless we remove all those objects. And if you see the first object you are putting in the stack will be removed, then only you will get the new value here. So now we'll come to what is a heap. So heap. Now let's lock another region called heap. So heap is, as you have seen, it's a very bigger size, right? It will be used for holding the main objects. So every created object which will be held in the heap and its reference will be held in the stack. Like if you see, we have a new string called test. We have a new list also, array list called test list. Now we are adding the new string into the test list. So what is happening? New string, the reference and test list is stored in the stack. However, the content of the string and the content of the list is getting stored in the heap. So what will happen? Every application will have only one heap. Okay, because we are having seen that multiple threads can have their own stack, but your whole application will have only one heap. It's reasonable because we have a very big object to pass and we cannot do all the things. So basically, stack will be used for local variables and there could be many stacks. However, heap will be only one. So now heap is not one solid region at all. So if you go into heap, you will see four different areas, which is called Eden, SO, S1, old and young. Now, what is this? These are called generation. So this Eden S0, S1 is called young generation, and this is called old generation. So let's talk about young generation. It is divided into three parts called Eden, Survivor 0, Survivor 1. And it is more clear when you learn what they do, right? So create objects are first place in Eden space. The Eden is fulfilled. Objects are moved to the survivor 1 and survivor or survivor 0. After created objects is placed in the Eden again, when the Eden is full, both Eden and survivor 0 or 1 will be moved to the survivor 0 or survivor 1. If the objects are moved more than 5, these objects are now placed in the old generation. So here's a key point. If the objects are moved more than 5, then this will be getting placed in the old generation. This means those objects are needed and will live in the old generation unless it loses the pointer. If there are no variable in the stack which will have the reference in the heap, we will come and our hero garbage collection will come. So one room for meta space, please. Meta space will be what? It will be the region where your meta space application metadata is stored. Most of the times, we do not know how and what is going on in the meta space due to its mission, right? And there is one or more mission than it has. That means it can hold static variables, it can have methods, it can have classes in it. This is why the static keyword is accessible from anywhere. Then what will happen is, can we tune the size? Obviously, you will have certain parameters like xmsng to set the initial size, xmx to set the maximum size, xx and new ratio to have the new ratio of the young to the old generation, new size of the young generation, and all those things. So this is how it was. I will try to make it more interesting from next onwards. But for now, I hope you have liked it, and do give it a thumbs up if you are hearing it for the first time. Thank you very much. Have a nice day. Bye bye.